Hello, welcome. Welcome everyone just joining for our first seminar together. How are you tonight? I'm Professor Sakin and looking forward to our term together. Glad to have you all. Doing well here, Ron, thank you. Welcome everyone, welcome if you're just joining. Great, Jordan, glad to hear that. Doing pretty well here as well. And looking forward to getting started with you all. So this name of a class might be new to some of you. Some of you may have heard of the area of math known as discrete math. If you haven't, that's okay. All of us come to the table with an interest in information technology generally, and it has a lot to do with that. IT related mathematics is kind of how you could broadly break down what discrete math is about. Hey, Tiffany, welcome. Welcome, everyone. Just joining for our first meeting together. We're just kind of chit-chatting here in the beginning, getting ready to start tonight's seminar. Welcome, Juana. All right, anybody have any questions right off the bat? I'll always have the floor open when we first start our meetings each week for any questions that you have. And also, if you have questions that might relate to something you saw in Zybook's homework or something specific, then I would recommend that you get in the habit of taking a screenshot of that, whatever you want to ask a question about later, and then email me that along with an explanation of what you tried or what you thought. And then when we have time during our breaks or at the end of seminar or at the beginning, I'll be happy to address those kinds of questions. But if you can, if it's about a specific exercise, if you can take a screenshot and send me what you tried about that, then that can really make it an efficient process, me figuring out what I need to say to you to kind of guide you to the next step, if that makes sense. Jordan, it is challenging. It's not extremely hard, I would characterize it, but it is challenging. Yes, so some good things that we will wrestle with throughout this term with discrete mathematics, and some good challenge is always beneficial in some sense. Gets you to be a little uncomfortable at times and stretch your boundaries, develop your skills so that they're sharper. No worries on that, Latoya. We're going to take a look at the discussion in just a little while. And Serena will take a look at the quiz link as well. Basically, you have 3 attempts, and you find those in the course in our even numbered units. So we're going to probably spend a little bit more time on quiz related how-to next week. Actually, I'll have to do that this week because next week I have to be away. So we'll do that this week, looking at quizzes and how that works. Basically, you'll have 3 attempts in the Brightspace course where we work, and the highest of those attempts will be transferred over to your gradebook. And you'll have 2 hours for those quizzes. They come every even numbered unit. Yep, Nathan, we're going to talk about those expectations for discussion. Jason, not necessarily in detail. That's where you would want to revisit the Zybook's material to see the concept again in Zybook's, and the questions will point you to that section that you could look at. If you got something wrong on the quiz, it would say, see section 1.3, for example. doesn't provide, say, that answer. Well, actually, it does provide the answer. It does provide the key in parentheses. So don't get confused by those parentheses. They are just there kind of housing the answer. You don't want to enter parentheses on the quizzes, but they will show you that, and it will also show you the section number where you can revisit that type of material. Yep, 2 hours for quizzes, Joshua. 3 attempts, Carolina. Zybooks. So I sent that video earlier, and I'm answering your question, Jordan. Any tips for learning discrete math in this course, in this format that we have designed for MM250? It's Zybooks. I sent that video out earlier today. You really want to get started in there early every week. That would be my suggestion for where you start first in every unit, is to open up your Zybook content and start working through the textbook. That not only counts for your homework, but it also gets you familiar with the material, start preparing for quizzes coming up in the even numbered units, and get some idea of what it is that we're going to be talking about in the discussions. So Zybooks is a very important place to kind of organize your time, and I would recommend jumpstart your unit. So spend some time early in the week starting to work through that Zybooks material for each chapter, and the chapter numbers correspond to our unit numbers. Woody, there are typically 20 questions for the quizzes. Michael, no. I just expect that you are working on a timetable that makes sense. So not all on one day. At least 2 days of the week, I would like for you to come into the discussions. Tiffany, you'll need to complete option 2 in that case, where you review the video of seminar and submit a summary. I'm sorry to hear you're not feeling well, but you always have that option in case of emergency. Talking about the Zybooks material, Dexter, it will take some time. That's why I recommend that you start early in the week. And remember, that is your homework, essentially. Completing all of those, what are they called? Practice activities and, no, participation activities and challenge activities. Getting through all of those is basically your homework for the week. And also, it's your opportunity to start getting familiar with material so that you can be more confident as you start drafting your discussion posts for the week. But yeah, it's going to take some time, and you want to get started early in the week on that Zybooks material. Absolutely. So here I have a to-do list for Unit 1, and now that I've said my hellos, I'm going to turn off the video here so you can see the slides a little bit later as we move through. For Unit 1, I have this to-do list for you. Take a look at your syllabus just to get a sense of all the expectations for the course, and then spend a minute in the introduce yourself discussion, telling us about yourself and 3 words that you would use to describe yourself, if you'd like to share with that. That's an interesting way for us to get connected and get to know one another. Then you're participating in seminar tonight, so you're earning your 10 points now by your participation. And then you'll want to complete your Zybooks lab homework. I would actually interchange numbers 4 and 5 if you were thinking about this in some order. I would recommend that you complete the Zybooks lab homework first, and then you draft your discussion post. And you might not have to do all of the Zybooks homework before you start your discussion, but by at least getting somewhere through those sections in the Zybook, you'll start to familiarize yourself with the material and topics for the week, and that way be ready to say something about the topics in the discussion. Not sure what your question was there about the discussion board related to 50/50. If you want to clarify what you were thinking there, Eric. And this is our first set of topics for tonight's material, but I'm going to spend a little time walking you through the course in just a moment, and then we'll come back to topic-related material for Unit 1. So let me share my screen with you. And let's go to, let's see, this page here. Yeah, the Hall of Mirrors, Michael, or Mike. That always happens in seminar when you first start to share. Okay, so let's go to our course homepage, just take a look around and get familiar with how things work on our course homepage. Notice that you have your tiles on the left. I've shown that you can link to zyBooks using this tile. That's a good place to start each unit. Then you have announcements over here as you scroll down to the right. And to view all of those announcements or all of the content for a particular announcement, click on the title and then scroll through. That way you can see everything that was shared in an announcement. I'll share videos from time to time that may be helpful. Just know that those announcements from the home page are cut off, and so you won't see everything unless you click on the title of an announcement. Just another view there. All right. Every once in a while, I will share something in the activity feed down here. Like here's another copy of the video there I emailed you earlier today. Coming up to our content menu in the course, some places where you can find materials are the virtual office. Click on the left-hand menu and then the link that pops up on the right. You can ask questions here if you'd like. Here is that video about zyBooks again. You can link directly to math tutors in the Math Center using this page. They're offline for tonight, but usually you will see during the evening hours green lights on some of them, and the knock on door button will show up, and that's how you meet with them live for tutoring, which I would highly recommend. And we also have a collection of our seminar PowerPoint that you can download a copy if you are one that likes to have the file on your computer and open it up later for reference or take notes during. You can download copies there. You're welcome. And coming back to our content menu, let's take a look at the Unit 1 content. You've got simple overview, and then you'll notice if you click on the reading, it just tells you where to go in our zyBook. For example, here is the zyBooks link over here, and it's just a short description of what you'll find in the reading. So typically, going directly to zyBook is going to be the most efficient process for starting a unit. And then you may also want to come to this link called the Live Binder. It is different for every unit. So let's take a look at what it looks like for Unit 1. We have a collection of tabs with titles that indicate the topic that is covered by that material under that tab. And so one of the first ones that you will see is the table of contents, and then that video about zyBooks that I sent out earlier. Notice it's also here. And then we got an intro to logic gates, logic statements, video, and logical connectives, and truth tables. Now this is a document. It's taking a minute to load, and it goes through some examples of logic gates. Some of the resources that you see in LiveBinder will be documents, and others will be videos. You're not required to work through all of these. These are an additional resource on top of guidebooks in each unit developed by our faculty to help guide you on any topics that you'd like to browse in this notebook. So you can see that document there with lots of examples of logic gates. And then here on the next tab is a video walking through some examples of logic gates, logical statements video, logical connectives, that's a video, and truth tables, another video. So use the titles to judge where you need to go. Like if I need more information about truth tables, then I might go directly to this tab. I don't need to necessarily work my way through every single one of these. And finally, let's come to the discussion for this week for Unit 1. In every discussion, you're going to see some examples. And so here are the instructions. Scrolling through the instructions for the first post, and then notice this link. Unit 1 discussion post 1 example. So this is a layout of how you might organize this particular post, post 1, or your initial response for this discussion. And you're welcome to take ideas from this format. Now, be careful. You should not take the examples themselves from these examples. For example, I shouldn't copy this table into my post. That's something I need to develop on my own. I need to come up with my own collection of the letters representing statements and the symbols of how I want to connect them, and then construct my own truth table using this template. Notice I fill in the columns of whatever I need in order to build up to that complex statement like this, but I'm not going to use that one because that's the one in the class example, right? So let's come back to the instructions and just kind of scroll through again. You're going to develop an idea for designing a system. Consider how 3 statements might be combined and evaluated by your system. You're going to use any collection of these symbols you would like. And you'll find out more about what those mean in our examples in tonight's seminar, as well as in your guidebooks reading. And then finally, you're going to construct that truth table for your complex statements that you came up with. So you have a little bit of an opportunity there to be creative in how you use these symbols, how you organize P, Q, and R for your statements. And then you can use this template and this as a guide for how you might organize your material. So you're going to be coming up with, your own sentences for P, Q, and R here. And you're going to think about how they might be combined. What does that look like symbolically? Again, it's not going to be this because this is just an example and you don't want to reuse it that we provide as a guide, not to replicate. And then here is an example of how you would carry out the truth table getting to this complex statement. You'll want to use your guidebooks practice and reading and watching some of those videos in LiveBinder, for example, to understand how you build out the rest of those columns based on whatever you decide your organization of P, Q, and R are going to be, along with connecting them with whatever symbols you choose in whatever order. Carolina, there are captions on the videos. Does that answer your question? You're welcome, Nathan. Looking down through, that's your first post, and then you're going to reply to a classmate. Notice there's an example for that one as well. Again, use this as a guide. Be careful not to use this verbatim. You can use some copy paste feature to a certain extent, right? You're going to have to edit some of it, or you can just look at this and replicate from scratch on your own Word document. Just be careful if you use the copy paste function that you're editing a sufficient amount of that example so that it does not appear as if any of it has been copied over. All right. Yes, Carolina, they have captions. Did that answer your original question? They have captions. Yes, Nathan, absolutely. You know, for example, what Nathan is saying is if you're going for this complex statement, you don't want to try to go directly to that column just from PQR. You want to think about, well, what are some smaller pieces that I can have for reference to help me visualize what that final complex statement is going to be. And if I evaluate Q or R here first, then I can more easily digest and kind of eyeball with the columns what P and the group Q or R will turn out to be. It's okay if you're very unfamiliar with what I'm saying there, but I'm just speaking to Nathan's point earlier about breaking down your chunks. Don't try to go directly from the template itself to your final complex statement. That's why you see multiple columns shown in this example template that you might start with. Use more than one extra column to build out or build toward your complex statement is the idea. Good, Andrew. I'm glad to hear that. I tried to specify as clearly as I possibly could what I intended for the instructions in these discussions. I actually wrote this course. So I tried my best, and I'm glad to hear you think it's pretty straightforward based on your viewing of it so far. And so that was post 2. Notice post 3 is to reflect on the relationship between mathematical logic and input-output system design, such as for apps, software, or operating systems, writing one well-composed paragraph of at least 3 sentences, specifically about what you learned from this discussion about the connections among logic statements, logical operators, truth tables, and input-output system design. So that's a little more open-ended post. So notice we don't have an example for something like that. That would be something that you come up with as a reflection and compose your own thoughts in a paragraph. Absolutely, Michael. If you want to use Excel, go for it. That's great. You're getting a statistics flashback. Hopefully a somewhat pleasant one. Shavor, is that right? I don't know what your experience was in statistics. I enjoy statistics now, but I know as an undergraduate, I did not. I like teaching it now. And Eric, yes, you can think about it as an assignment. Our discussion boards in math are assignments. Contrary to what you may have experienced in another course where a discussion board was more of a chat with your classmates, you want to think of our discussion boards in this class as an assignment. Absolutely. They're graded and they're 30 points each week. 18 points applies to post 1, and then 6 points each to post 2 and 3. All right, so I think that we have had a good visit in our course. Does anyone have any questions about anything that you've seen so far? Nathan, you are welcome to work ahead in the guidebook. It is completely wide open. However, I have no ability to change anything related to the quizzes. So as soon as you see the option to visit the Unit 2 quiz, that's when it is available. I don't have any authority or authorship on changing the due dates or start dates on our quizzes. And I want to say that Unit 2 quiz, you're allowed to start first thing next Wednesday morning. For your guidebook lab homework, you can begin for any unit at any time. Great question. All right, so let's get out of there and back to our slide. And I'm just going to advance the slide here, but we're going to start off our discussion with statements, negations, and quantified statements. I'll just have kind of a joke sort of slide here for us to look at first as we kind of take a breather from our field trip into the course and get ready to get started on some examples from Unit 1. You can enjoy this for a moment, take a breath, and a sip of water or whatever you want. If there are any other questions about where to find something in the course, feel free to use this time for that as well. All right. I like to throw in some little breaks here and there. If you enjoyed that, great. You didn't have to. I'm not requiring it. So, let's talk about what we mean by a proposition or statement. The most basic element in logic is known as a proposition. A proposition is a statement that is either true or false. It can't be ambiguous or opinion or both. It must have either the value true or the value false associated with it. You can also think of it in that on-off or 0-1 format. Yes, absolutely, Mike. And that is, often a good sort of translation for computers, right? That 0-1 structure. So let's look at these examples. London is the capital of England. That has a value true. William Shakespeare wrote the television series Modern Family. That has a value false. We can clearly assign those truth values to those two examples. Now, commands, questions, opinions, these are not statements because they can't be assigned a true or false value. For example, the Titanic is the greatest movie of all time. Bless you if that's your opinion. It's a great movie. I would not say that. But anyway, you get the idea that depending on the person, you cannot necessarily assign true or false definitively to that statement because it is an opinion. A command like read pages 23 through 57 is of the same sort of characteristic. We can't say that's true or false. And then a question like, if I start losing my memory, how will I know? That can neither be true or false. Now, when we want to represent our propositions or statement in symbolic logic, we use lowercase letters typically, is what you'll find in the literature for mathematical logic. And typically they start with letters P, Q, R, and S. That's just by convention with textbook writers. It's not set in stone. You could certainly start with X, Y, Z, A, B, C. We're going to just go with the flow here and start with labeling our statement P, Q, R, and so forth. So if we wanted to label those two examples we looked at earlier, we could define P to be the statement, London is the capital of England, and Q to be the statement, William Shakespeare wrote the television series Modern Family. Yeah, like could be anything. The negation of a true statement would make it false, and vice versa, the negation of a false statement would make it true. So let's think about our example, Shakespeare wrote the television series Modern Family. How would we negate this statement? We could say Shakespeare did not write the television series Modern Family. That would change it from being false initially to true. It is true that Shakespeare did not write the television series Modern Family. So notice how we're changing the truth value by inserting words that negate this original statement. You can always negate a statement by simply tacking on, it is not true that, in the beginning. But whenever you have the opportunity to inject natural negating language like that, it's usually a better narrative outcome, right? But mathematically, or in the just strict logical sense, it's no different from simply saying it is not true that, and then spell out your statement after that phrase. Both of these sufficiently negate the original statement. Shakespeare wrote the television series Modern Family, false. We make that statement true by saying Shakespeare did not write the television series Modern Family, or by saying it is not true that Shakespeare wrote the television series Modern Family. Yeah, you can think of it in that way, Andrew. Absolutely. How about we negate this sentence, today is not Monday. That is true currently, right? So it qualifies as a proposition. We can assign the value true to this statement. Today is not Monday. And we could negate it by saying today is Monday. Right, Chad? Right, Jason? Very simple negation here. Or we could go the route of saying it is not true that today is not Monday. But notice how that's getting to be a bit much. It's also a double negative. So it's not always the best natural language to use that tacking on to the beginning. It is not true that. This is certainly the better English version of negating that statement. We went from it being true to false. And I know some of you are kind of thinking, well, it depends on the day. Well, yeah, if it were Monday, then the truth values of these statements would change, but they would still be known. There would be no ambiguity about it. So think about the truth value as being, is it defined at this cross section in time? Or can I say with certainty what that truth or false nature of the statement is right now. If the answer is yes, then it qualifies as a proposition or statement. So don't go on the tangent of when was this statement made. Just think about it in the now, in the right now. That helps. Jordan, that's a great question, and one for philosophical debate, right? When mathematicians and philosophers were developing this area of study, they probably said, okay, well, what if I want to know the alternative? Or what if I need to evaluate some thoughts that have to do with the alternative to any statement? And that's essentially the underlying reason. And also, let me tack on to that. It sounds like you're kind of the idea that we're attempting to achieve true things. And yes, truth matters as a sort of cultural goal, right? We want to know things that are true. We want to express things that are true. But that's not a goal in mathematical logic. Kind of dispel your or put away your natural inclinations to want to tell the truth or for things to be true. That's not a goal when we're doing math with logic statements, okay? We're going to evaluate a variety of statements of various nature. Some of them will be true while others are true in conjunction. Some of them will be true while others are false in conjunction. And so we are getting ready to, be able to evaluate in all possible combinations we might come across of things being true or false. If you don't like thinking of them in that sense, just think of them as 0 or 1. Do I not place an action on this statement, or do I place an action on this statement? You can think of it in that way, 0 versus 1, because that's where I think many of you will see the light more so, is how is a computer going to handle these statements? If it's got a 0 on it, it's not going to take action on that, right? If it's got a 1 on it, then it's going to take action on that. Or more broadly, because not everything is about an action, right? If it's got a 0 as its outcome, that translates to a certain output of the app or the software. If the user did a bunch of stuff, entered a bunch of things that translated to 0s and 1s, and then some combo of all of that came out 1, then that translates to a certain outcome or output from that app or software. So that's a larger question. It depends on your project and your intent. If you're using logic to build an app or some software, Jordan, if you're talking about for the purposes of our course, then the instructions will be given, so it'll be clear. Great question. All right, so here we're looking at the symbolic form of negating statements. If we have P as Shakespeare wrote the television series Modern Family and Q, today is not Monday, how would we express item A there? Shakespeare did not write the television series Modern Family. Symbolically, that would be not P as you see there symbolically. And then our textbook uses kind of a similar symbol like this, a more straight edge tilde than the curly tilde. Either of those means not that statement. or the negation of. And so today is not Monday, is the negation of Q, not Q. So that's how we can express those statements symbolically, given their original definition in terms of P or Q, and then after they've been negated, then symbolically that translates to not P or not Q. Quantifiers, we're not going to spend a lot of time on quantifiers. That was more of our old course design. I'm going to jump forward here to compound statements and connectives. So simple statements, like we've been looking at, convey one idea with no connecting words. Compound statements or complex statements, like you're going to build for your discussion posts, remember, combine two or more simple statements using connectors. Connectors are words used to join simple statements such as and, or, if then, and if and only if. So the and connective, if P and Q were two simple statements, we could join them by P and Q, which symbolically looks like this. I remember it because that looks like an A almost. That symbol is almost an uppercase A for and. If we had these two statements for P and Q, then looking at this one, it is after 5 and they are working. That's a simple combination or complex statement built from P and Q above. How would we write that symbolically? The caret symbol, you can see shift 6. Right, Nathan, thank you for sharing that. P and Q for that first one. Looks like we've got some consensus around that. Thank you all for sharing that. Excellent. Now let's turn our attention to B. It is after 5 p.m. and they are not working. How would we symbolically express that example? Good. We're using the and symbol and the not on the Q, because Q is negated there. It was originally defined as they are working, and we're looking at a translation, they are not working, so that is not Q. Good. Or, I think I skipped a slide, maybe not. The connective or can mean one of two things. It can mean I visited London or Paris, or both. Exclusive or, like XOR, or do we have that in the discussion symbols? Yeah, we have it as one of the possible symbols as a circle with an X inside it in the discussion instructions for exclusive or. And then inclusive or is the and symbol turned upside down, or. So what exclusive or means is I did one or the other, but not both. And then inclusive or is the natural interpretation. So if you don't see but not both, or both, then we naturally shift to inclusive or. That's the universal one, the universal interpretation. Unless otherwise stated, you would assume it's inclusive or. If it's clearly stating but not both, then you translate it as exclusive or. All right, so if we were wanting to make a disjunction, as it's called, then we would use that symbol. P or Q would be symbolized in this way. For example, if we have P and Q defined here, and we wanted to express A here, the bill receives majority approval or the bill becomes law, then we can use the or symbol along with P and Q to write that. And you can go ahead and share if you want. I'm just going to share these so that we can move on. and get to truth tables, which we'll want to practice a little bit before we end tonight. So yes, you're getting the idea of P or Q on item A there. Good. That is in the second item B. We have a negated form of Q. The bill does not become law is not Q for part B. Then there are other connectives like if then and if and only if. And I encourage that you work carefully through the Zybook's examples to understand those with greater detail. You can use V, CJ. Oh, exclusive or. You can copy paste the symbol as it's given in the discretion in the instructions, or you can just use this abbreviation. XOR is a common way of expressing exclusive or, because I realize that circle with the X in it is hard to type. It's hard to build into any typeface. Good question. If you want to try and copy and paste it from somewhere, you're welcome to, or you can just use XOR. Yes, Deborah, and this translates exactly to how Python and R and Stata, and if you're building on the back end of Excel with VBA, all of those types of coding environments rely on mathematical logic. Equal is not a logic operator or connective, Andrew. And that takes me back to, starting early in the week with your Zybooks content, because that's really where you're going to see, oh, okay, these are all of the symbols that go along with mathematical logic. I've seen some examples from working through some of the participation activities. So that Zybooks interaction is really where you can build some clarity on how to approach the discussion material. Yes, Jordan, absolutely. All right, so here's a breakdown of all those connectives that we've looked at so far and that you can use. You can feel free to use if then and if and only if too in the discussion. You're not limited to those symbols which are suggested in that little table of the instructions. Feel free to use any logic operators that you find in your reading through the Zybook. That's cool, Eric. That's awesome. Glad that you're making that connection. It's what we're doing this week. Yeah, absolutely. I hear you. All right. So again, this is stuff you can come back and revisit if you want more detail, not something we focus on in the current version of the course. We do, however, place a lot of emphasis on truth tables because this is where you can really start to map out, okay, what paths might my user for some type of software design or some type of learning software, learning, like interactive learning modules, when you click on something and it pops up a question and then it makes you click on an answer, and if you don't get it right, it's going to be feedback, and there's so many paths that one can go down on an app or piece of learning software or whatever the system design might be intended for. And so truth tables are kind of a not necessarily exhaustive view of what that path might entail, but they're a good starting view, I would say. Or if you were going to break down what users may input and then view as output, then they're good ways of breaking down simple steps throughout your program. So let's say that your user comes along and it says yes or no. Yes or no. That can be translated to true or false, right? And then if you're going to present some content that basically negates their input or tells them to, think about this alternative, maybe, then the opposite truth values that would be translated from that original input, when we negate something, we get the opposite. So we would take something true and it would become false, or if it were false initially, then we would take it to true or translate it to true. So this kind of goes back to someone's question earlier, why would we want to evaluate statements which are false initially or negate statements that are true initially? What we're really thinking about or thinking through is the process of translation through some series of steps, right? When you go and open your banking app, you enter your, username and your password. And when you click on the button, the system checks those to some database, and then it's ready to say, okay, yes or true, this person has entered their information correctly, or false, this person has not entered their information correctly. And those output then translates to what that user then experiences next. And so when we think through all of those possibilities, taking a true statement, negating it, taking a false statement, and negating it, we're getting ready for all of those potential interactions that might take place. We're considering all the accommodations, in other words. So that's just for negation. Then if we're considering conjunction and disjunction, or and or, we have to be dealing with two things simultaneously, two inputs, P and Q, for example. And for conjunction or combining them with and, that translates to true when both inputs are true, or both simple statements are true, otherwise false if either one of them is false. That's the logical output for an and operator. Logical output for an or operator is true if either is true. Remember, one or the other or both is how we think of it. So if one or the other or both are true, then our output is true for the or operator. All right. So let's suppose that we were going to consider this as our final outcome, not the complex statement combine P and Q. So in order to get there, it's best to consider all the possible combinations of P and Q being true and false. And so in order to ensure that you scroll over all of those possible combinations, I recommend that you split the first one down the middle with true then false, and then you toggle the next one. That way you've considered every potential instance of P versus Q being true or false, and it's, conjoined with, or it's combination with the other statement. Notice we have P true and Q true, P true and Q false, P false and Q true, and then both false. So that's all of the possible combinations of truth values for those two potential inputs. All right, trying to translate this to a real life example. Suppose that we can just go back to the banking app, right? Think of your username as P and your password as Q. We would want both of those to be true in order to let the user access, right? So and would be the best operator to use. If P were your username and Q were your password, you want both of them to be true in order for the outcome to be true. Anyway, that's just a lens to how it might be applicable. Let's finish this truth table. And means it's true if both are true. So we got true, false, false, false. So notice how we can now, in building our final output here, look to column 3 and easily decipher what this is going to be. That would not have been the case if we were just staring down those first two columns. We would not be able to see that very easily. Restrict your view to these two columns for a moment. Imagine trying to go here, not as efficient, right? So that's why earlier when I was saying use extra columns in your truth table as you're building towards your complex statement in the discussion, that's why. Make it a kind of easy step-by-step process. Think about how to break down your complex statement into more manageable pieces. That's kind of a step-by-step through that we just did. And here we go with another example. We've got not P or Q and not Q. So again, we want to toggle down the middle with true, false, and then toggle Q. Let's just walk through this. This is our initial setup to ensure all the combinations for P and Q. And then we've got not P involved, right? So notice we're going to make a column for that. Negate P in column 3 here. Then we've got a group of stuff in these parentheses. So let's make a column for that. Now that we can easily look at not P, we can build this column from columns 2 and 3, right? Look at those and operate with the or. So either be true and outcome is true. Then coming up, we have a not Q. So let's write that down in a separate column so we can easily see that. And then finally, we join these two columns to form our final complex statement with and. So we look to here, are both of these true? Nope, so that's false. Are both of these true? Nope, so that's false. Both of these true? Nope, that's false. Both of these true? Yes. So that turns out to be true with the and operator there on those last or next to last two columns to get to our final one. So that's kind of a, more detailed or more involved look at how these truth tables can unfold with some additional operators thrown in there, some negations and so forth. So again, don't be afraid to build out your truth table, and you may be looking back at that discussion table and noticing 3 inputs, right? Well, if you have 3 inputs, then your template start looks different. You split P down the middle, you toggle every second for Q, so 2 trues, then 2 falses, 2 trues, 2 falses, and then you toggle every other line with true false for R for your third statement, and then you're ready to go building out other columns for those 3 inputs of simple statements. And that's going to be your task for the discussion. Remember to visit your Zybooks material to build some familiarity with how these truth tables work. You've seen some examples that I've shared with you, but by doing the activities yourself with some truth tables and then building up your confidence to using 3 statements with the Zybooks material is really going to allow you to ease over into the discussion and draft that initial post. So I hope that you have fun with this week. I know it's a kind of a little different area of mathematics than you may be used to, this mathematical logic. Next couple of weeks are going to be more computational, if that's more your cup of tea or what you enjoy, more computational math. It's coming up, don't worry. This week, it's all about how to translate language into operators that we can, say feed a computer or an app or a software program and evaluate for various depths and then get some sort of output in the end. So interesting stuff this week. I hope you enjoy it. And email me at any time if you have any questions. Next week, we will not meet live. I will send out a notice first thing Wednesday morning of next week explaining what's going on, but I have to be away next Wednesday for Unit 2.